right. So, hi, it's me, Dr. Prickett. This video, I was going to say today, but you're probably watching these on the same day. Maybe not. In this video, we're going to be doing our first Python lecture. So if you haven't already seen the video where I go over the syllabus and talk about the history of computational linguistics as a field and all that good stuff, make sure you go watch that first. It'll kind of explain the structure of the course a little bit to you. If you can't find that and you've only found this video and you're somehow like lost on Moodle, email me at bprickett, Prickett, @umass.edu, and we'll get things straightened out. All right, but let's get started. So this class, like I was saying in the other video, is going to be using something called Colaboratory, which is a resource that Google provides for free online that lets you run Python programs in your browser. So hopefully what you're seeing right now is that I have Google Chrome open here. That's just the browser I like to use. It works on things like Safari. I think it's supposed to work on Firefox fine. So you can definitely use other browsers as long as they're not some really obscure one. The way you access it is you go to colab.research.google.com. What happens for me is I get this little pop-up. You might see something a little bit more like this, where it's introducing you to the idea of Colab if this is your first time. If you got the pop-up, there was a little button called New Notebook, and you'd want to click that anytime you were starting a project. For this, if you show up into a spot like this, you just come up here to the top left, and you can click New Notebook there. So a Colab file is called a notebook. So Python notebooks are kind of like a thing outside of Colab too. You can download the notebook, and if you've got the right software, run it on your local computer. We aren't going to have to do that for anything in this class. All you'll do is click New Notebook, and it'll bring you to a screen like this. And we'll kind of go through all of the different things you need to worry about. So thing number one, up here in the top left, this is just the name of your file. So I'm going to just call this Python Lecture 1. And now this is saved in my Google Drive. So if you've ever used Google Docs or Google Sheets or anything like that, that are saved into your Google Drive, you know exactly how that works. You have to have a Google account. It gets saved there. I forgot to mention that actually in my last video, or like the main lecture video for this week, but do make sure you have some kind of Gmail account to use. When I was a student at UMass, everybody got a free Gmail account. I think that's still the case. You should be able to just use your UMass account if you want, but you don't have to if you've got another Google account you prefer using, where you have all your stuff saved. You can totally use that as well. But you've got a Google account, so you can see mine over here, right? I'm logged into that. I've now named my file up here in the top left. My Python code is going to go here in this gray box. So right now there's only one line there, but I can push enter and make as many lines as I need. And I can type into here anything I want. And when I push this play button here, it's then going to run my Python code. So let's get started with that. There's a lot more going on here. I know there's tons of buttons everywhere, but I want to focus a little bit more on just getting into the Python today. And as we need some of these other buttons and things, as the semester goes on, I'll introduce them then. So the very first program you always want to write when you're learning a new programming language is a hello world program. And that's just where you get your computer to say hello world to you. Not even say it, just, write it out, right? So the way we're going to do that in Python is we're going to use the print function. So if you are familiar with Python, but you've used Python 2, you didn't need these parentheses here in Python 2. This class is going to be in Python 3, though. In Python 3, you need parentheses next to your print statement. So anything you put inside the parentheses of a print statement is going to get printed out. And not like on a printer or anything, right? Just here on our screen down below where our code is. So Colab is very nice in that it puts your output right below your code. So you see it nice and immediately, and it's easy to kind of keep track of things that way. So inside of our print here, we're going to put double quotation marks. And then we're going to put the words hello world. So now what I have here is a piece of Python code. Nothing else is needed. And so I can hit the play button and it'll run that code for me. So you can see over here, it's connecting to the computer that this program is actually running on. It doesn't actually run on your computer. You're using your browser to communicate with one of Google's computers remotely. So it sent that code to that computer, connected, and then ran my program, and it prints out hello world right there. If you want to clear the output, you push that X, you can run the program again. Now I'm already connected, so it runs a little faster. So now we know we've got our Python working. We know we're connected and to Colab and everything, and that side of things is working well. So now we can actually get down to some of the basics of Python. So what we're going to talk about today is operators and data types. So those are kind of two pieces to the puzzle of any programming language. They're two tools you need in your tool belt to really make any program. So let's talk about the first one, data types. So this here is data, right? We have the words hello world, and you're telling the computer that this data needs to get printed out. You're giving that information to this print function. The kind of data, the type of data that this is called a string. Oops, wrong kind of comment there. There we go. So this is a string, and what strings are just text-based data, right? You can put letters, numbers, symbols, whatever you want inside of these double quotation marks, but anytime something is inside of double or single quotation marks in Python, it's going to be a string. So we could also do hi Earth, and it's in single quotation marks, but it's still a string. Over here to the right of my strings, I've also got something that I should introduce. So these are comments. Because computer programs can sometimes get a little hard to read and understand, they almost always come with this capability to leave comments in just plain English or whatever language you want to leave your comments in. So in Python, the way this works is you put this little hash symbol or pound sign, hashtag, whatever you call that. You put that symbol there, and whatever you type after it, to the right of it, is not going to be looked at by the computer. The computer ignores all of this when it's running your code. All it cares about is the stuff that either doesn't have a hash symbol on its line, like this, or that is to the left of a hash symbol. Anything to the right gets ignored. And so you can put things like this, right? Labeling that this is a string, labeling that this is still a string, stuff like that. So strings are our first kind of data type. The second kind of data type that's going to be important for us is numbers. And numbers come in two flavors, or at least two main flavors in Python. So what we're going to have in our numbers are integers and floats. I spelled integer wrong. There we go. So an integer is just any whole number, right? Exactly what it is in math class. So if I say 1 or 999 or -3, right? These are all integers because they're whole numbers. They can be positive, they can be negative. They can't actually be as big as you want, but they'll usually go as big as you need them to. The highest integer that Python can handle is pretty high. Floats are numbers with decimals, right? So here are integers. Here are some examples of floats. So 0.001, 1.5, 1000.2, -0.075. These are all floats, and they're just floats because they're not whole numbers. So anytime you need a decimal to represent the number that you're dealing with, that's going to be a float. Anytime you've got a math problem in your program, if there's a float in the math problem, your answer will be a float automatically. So Python will kind of handle that for you as long as you've got a float in there. So those are our numbers, floats and integers. Next kind of data type that we want to worry about is called a Boolean. So a Boolean is a little simpler than strings or numbers. These are just true or false values. So for example, I can say the word true, and as long as I have that first T capitalized, that's going to be a Boolean value for us. So that is a true value. Here's a false value. Again, I had to capitalize the first letter, the F there. But now I've got true and I've got false. So Booleans, yeah, let's go ahead and fill all of these in. Those are always true or false. All of our data types in Python can be printed out too. So we already saw how we can print out a string, right? Do it like that. And we can also do it with single quotes if we wanted to. But you can also print out a number like 5 or 5.324. And you can print out Booleans. So notice again, right, the Booleans don't have quotation marks around them. If I put quotation marks around this, then it would just be a string representing the word true, right? Not the value true that you might want to use in your programs. So no quotation marks, capital first letter to make it a Boolean true. All right. So we've got 3 data types now. So those are sort of our most basic tool that we're going to use in our programming. The next tool that we want to have are operators. And operators are ways of combining data. So, for example, we've got mathematical operators, which combine 2 numbers into a single number. Oops, wrong button. Don't need that right now. So that's really easy, right? Again, just like they work in math class for the most part, if you say 3 plus 7, and you've got that inside of your print statement, you're going to print out 10. If you say 3 minus 7, you're going to print out -4. Something to keep in mind for multiplication and division is that you don't actually have keys on your keyboard for those operators, right? So you can't just say like 3 times 7 like that with an X. That's not how you do it. Instead, what you end up having to do is an asterisk. So that's going to be our multiplication operator. If we print that out, it's going to be 21, 3 times 7. For division, it's a little more intuitive. It's a /, so it makes it kind of look like a fraction. But again, you don't have the regular division symbol you used in like high school math on your keyboard anywhere. So we have a / to do division. And if I do that, then it gives us this. So 0.4285714, whatever 3 divided by 7 is. We do 21 divided by 7 just to get a nice even number, 3.0. There we go. So those are your kind of 4 normal mathematical operators that you're probably pretty used to. You can also do exponents in Python by putting 2 asterisks. So 1 asterisk is multiplication, 2 asterisks is exponents, right? So this is saying 4 to the power of 2, which is why you get 16. If you did 5 to the power of 3, you'd get 125. Oops. Because that's 5 cubed. Let me keep track of these 2. So we've got plus, minus, multiplication, division, exponents, and there's one more. And this is not something you use usually in math class, but it's something that comes up in programming a weirdly often amount. And that's modulus. So this % sign here is going to do a kind of weird thing. It's going to take 5 and divide it by 3. But instead of giving you the fraction that is, right, 5/3, it's going to, or the decimal that corresponds to that fraction, it's going to do the division problem like you would in like middle school or maybe elementary school, where it says that 5 divided by 3 is 1 with a remainder of 2, and then it just gives you the remainder. So let me kind of show you what I mean by that. So it just gives you the 2 here as your answer. So 5 modulo 3 is 2 because 5 divided by 3 is 1 with a remainder of 2. And so if you don't remember how remainders work, right, you do the division problem and get your answer and essentially round down, right, and then see just how many whole numbers away you are. So we can do a different example here. 15 modulo 3 is 0 because 15 divided by 3 is 5 with a remainder of 0. 3 times 5 is 15. You're good. 16 modulo 3 is 1 because 16 divided by 3, well, 3 times 5 is 15, and then you got to go one more to get up to 16. So you get the 1. 17 is going to give you 2, but then 18 is going to give you 0 again because 3 times 6 is 0. So 18 divided by 3 is 6 with a remainder of 0. So that's modulus. Like I said, very useful in programming. I don't think any, like at least grade school math class ever uses that. So those are our mathematical operators. They let us take those number pieces of data and take 2 of them and combine them into 1. And I know a lot of this is kind of abstract, right? We're not doing anything with it yet. But like I said, these are just the tools we need to start doing anything. So bear with me here. I know it's kind of boring. We're just kind of stepping through information, but I promise it's good information to have. All right. Next kind of operator is a concatenation operator. And this combines 2 strings into a single string. So, for example, if I say print hello, and then I did the plus symbol, and then I did world, these are each strings, right? They're separate strings. This is just hello, and this is just world. But because I have this plus symbol in between them, it's actually going to combine those into a single string. So when I push the play button here, now they're squished together. They've been concatenated. And the concatenation operator is the plus symbol, just like the addition operator was. So that can get kind of tricky sometimes. If you were trying to put like a number here and you tried to run this code, it's going to give you an error. So in Colab, you know you've got an error because your little play button turns red and it tells you the kind of error you've got down here. So it's saying you can only concatenate strings, not integers. And so that's the problem. We'll probably learn later on in the class how to deal with this if you actually did need to print out that 5, right? But for right now, just don't mix numbers and strings. That's the easiest way to avoid that. So that's our concatenation operator. It's simple. There's just one of them. That's how we combine our strings. Next up, we've got our logical operators. And these combine 2 Booleans into a single Boolean. So if you've taken like mathematical logic, you'll be super familiar with these. These will be super easy for you. So let's see here. We'll do print like we've been doing, and then we'll do just one Boolean to start off with, right? So remember, we can print out Boolean values, true, true. Logical operators look like this. So here's the word and it lets us put a Boolean on either side of that, and it's going to combine them in a particular way. So the way the and operator works is if you give it 2 trues, it'll combine them into a single true value. And we can see that. I'll push play, and we got true there. But if you give and anything else, so a true and a false and a true, 2 falses, then it's going to give you a false value. The way to think about this is it works kind of like and does in like English, right? So if I say the person has brown hair and blue eyes, both of those characteristics have to be true of the person, or else I'm lying, or else the sentence is false, right? So that's why and is only going to give you true if you give it true and true. So our first one here is and. The next one is going to be or. And or is the opposite of and. So if we give or two falses, it'll give us false, right? That's what I just did there. But if you give or anything else, so if you give it a true and a false, or a false and a true, or two trues, it's going to give you true. And again, you can kind of think about this as working the same way it does in English. So if I say the person has brown hair or blue eyes, then as long as either one of those things are true, my sentence is true, right? If they're both true, it's still true. Like, depending on exactly what kind of things are implied by my sentence, right? The exact contents of the sentence might make my or a little bit more complicated, but in Python, it's not complicated. If you give it two falses, it gives you a false. Anything else, it gives you a true. Then the last logical operator is not. So that's actually only going to take one Boolean. So I kind of lied to you, right? I said that operators take two things, combine them into one thing. That's not actually always true. This is one case in which it's a lie. So not is going to take a single Boolean like this and just change it to be the opposite. So not true, that's going to print out false. If I say not false, it's going to print out true. If I say not false, it'll print out false. If I say not false, it'll print out true, and so on and so forth. It works like negative signs do in multiplication, where it's always just going to flip. All right. Last kind of operator we're going to worry about today is called a relational operator. And in Python, these are going to combine two of almost any data type. All the data types we've learned about today work with relational operators. We'll learn about some more data types over the next few weeks that don't all necessarily work with relational operators, but these are going to combine two of almost any data type into a single Boolean. And these are something that sounds kind of very complicated and weird, but it's something you're very familiar with from math class as well. So, for example, if I say 2 is greater than 3, that is false. And this greater than sign is a relational operator. It takes these two numbers and combines them into a Boolean, false. And that's why you get that right there. So relational operators, we're going to have greater than or equal to. So if I said 2 greater than or equal to 2, that's now going to give me true because 2 is greater than or equal to 2. And again, just like with division and multiplication, right, we don't have a greater than or equal sign on our keyboard. And so when we're programming, we're just going to use the two symbols next to each other to be greater than or equal to. They just have to go in that order. First the greater than sign, then the equal sign. So we'll have greater than or equal to, less than or equal to, equal to. So this relational operator is equals, right? So if I put this, that's still going to be true, right? 2 does equal 2. If I put -10, it's going to be false because these are not equal to each other. So because our equal sign is used for something else in Python when it's by itself, it's what's called an assignment operator, which we don't need to worry about quite yet. But because of that, you have to use two equal signs together to get you the relational operator equals to. And then you also have not equals. So that's just the opposite of equals. So you replace that first equal sign with an exclamation point, and that's because exclamation points are often used to mean not in programming languages. Even though in Python we just use the word not, the exclamation point still kind of sneaks in here. So if we print this, we now have true, because it's true that 2 is not equal to -10. So just to kind of review, right, we've got 3 data types we've learned about so far: strings, numbers, and booleans. Numbers come in 2 flavors: integers, which are whole numbers, floats, which have decimals. And then we've got operators, which are ways of combining that data in our program. So we have mathematical operators that combine numbers, concatenation operator, which combines strings, logical operators, which combine booleans, or sometimes just takes one boolean and changes it around a little bit. And then we've got relational operators, which take other things, compare them to one another, and turn that comparison kind of into a boolean, right? So I forgot to show you, but we could also say bat equals bat. That's going to be true. If I change this to cat, it's now going to be false. So we can also compare strings. I wouldn't recommend using these relational operators with strings. They do things. They essentially like convert the strings into numbers and then compare those numbers to see which is greater than or equal to, or greater than or less than, or things like that. But that's not usually very helpful. So equals is good. Not equals works well for strings as well. Less than and equal to, greater than and equal to, those aren't quite as helpful for those. You can also use it for booleans. So I can say, does true equal false? And it doesn't. Does true equal true? It does. But that's also not going to be that useful that often. So that's what we've got so far. Let me pop open the syllabus here and make sure I'm not forgetting anything. Good. Okay, cool. So that is all we had to talk about today. I wanted to show you the print function, which, remember, gives you this output down below your code. I wanted to show you how to use Colab. If you have any trouble getting Colab working or getting a Google account working or anything like that, definitely let me know. But I would recommend, before you have the project to work on in 2 weeks from now, go ahead and try and create a Colab notebook like I just went over here. Do a hello world program for yourself. Make sure that it works for you so that you know you're good to go. We'll have 2 more Python lectures before you actually have to start doing any coding, but just to make sure. All right. So this one was kind of short. They might be longer in the future, but for now, the Python lecture is done. I will see you all. Well, I guess you'll see me in a video next week. Bye.